My name is Justin Dragna. I am the Director of Science and Development at Applied Nanotech, and we are presenting at Sea, Air, and Space on the work we did with our Navy grant. Specifically, we designed high-viscosity pre-penetrant etching materials. What are those and why are they important? So say that you have an F-35, so an aircraft. Over time, the aircraft wears out, different parts wear out, become fatigued, and you need to replace them. But predicting when they become fatigued is difficult, so you need to test those parts sporadically to see if they've worn out. So how do you test a part? Well, currently, the method that you take on is to take the plane apart, remove the part that you're interested in, and then you have to go through this pre-penetrant etching process. And what you do is you take this part and you dunk it into strong base and strong acid, and that removes the surface coating on it. And then once you've done that, you can go through and do what's called non-destructive inspection, where you take a fluorescent dye and you put it on the part, and that will reveal if there are cracks in it. So it'll show you if you have something like this, you put a black light over it, and it'll be fluorescent where the cracks are. In order to reveal the cracks, that's where this process of dunking it in the strong acid and base comes from. It starts out where you can't see them, you etch away the surface, and it gives you the cracks. So obviously taking a part off of an aircraft is time-consuming and difficult, and you would prefer to leave it on. And that's where our technology comes in. We created these high-viscosity etching materials, and you can take these and apply them to the part while it's still on the aircraft. So now you don't have to take things apart. Additionally, because they're high viscosity, these are pastes, they don't splash around. So whereas before you had this concentrated solution of acid where you dunk your part in, and if it gets on your skin, it's a real hazard, now you have this thick kind of toothpaste-like material where the danger of getting it on yourself is significantly lower. So this reduces the amount of time that you have to put in order to test the different parts on an airplane for fatigue.
And what are you trying to accomplish at Sea, Air, and Space today?
So at Sea, Air, and Space today, we're trying to connect with different organizations that deal in aircraft, so places like Lockheed Martin, and also speaking to people in the Navy and trying to understand the demand and the market size for the product, and trying to actually translate our kits, which are more or less ready in terms of going to market. We're trying to translate that into commercial sales. And STP has been very helpful in that. Our business consultant, Anthony, has done a great job of introducing us to a variety of different potential customers and people who work in the industry, which is really important in terms of figuring out market research. So, we have a list of maybe 100 people that will speak to us that he's given us contacts for, so we don't have to just cold email strangers and hope that they get back to us. And that's a really, really invaluable part of transitioning something from research into commercial. So I would say what STP has provided has been invaluable.